All right, hello everybody. This are kind of problems we did in class today that were on the board, and I just kind of wanted to run through these, at least get the setup of them, and then obviously I think you guys can handle it from there. So I'll give you the general setup, but I'm not necessarily going to solve the whole thing because we had a lot of questions today, and I just want to make sure everybody's on the same page of things. The goal of these particular problems, 1 through 7, is to get a common base, and we're going to manipulate these particular bases so that they are the same. And in doing so, it's going to affect the exponent. So let's take, for example, number 1 here. All right, so we have 1/3 x plus 2, and then we have times 1/9 x plus 1. All right, and so the goal here is to manipulate these bases so that they are the same. Now, there's a couple different ways to do this. I like to just use exponents. We can certainly square root this, but it makes things a little bit complicated because then we're taking exponents into fractions, which we didn't talk about too much today. So what I want to do is I'm going to change 1/3, or I guess, sorry, 1/9 into 1/3. So if I can do that, we have 1/3 x plus 2 and times, and I can change this to 1/3. 1/3 squared, 1/9 is the same as 1/3 squared. I'm kind of using bad things here because I'm supposed to be taking 1/3 squared or taking all these things to the appropriate parentheses, but I'm trying to kind of clean things up a little bit. But we're taking 1/3 squared, and then we also need to take it times the exponent that already exists up there. So really it's 1/3 x plus 2 times 1/3 2 times whatever already is the exponent, because 1/3 squared is the same as 1/9. So all I'm doing is kind of like making equivalent fractions. So in doing this now I have x plus 2, or 1 over, I'll make this a little bit more mathematically correct by putting parentheses around the base, 1/3 2x plus 2, and then from this point on we're going to use our thing from number 1, which is our rule number 1, which is that we can now add these. If they have the same base, we can add the exponents, which you'll come up with, let's see, 3x plus 4. All right. Also make sure that I've done this a couple times, but make sure that when we distribute this, we distribute to all the terms within the exponent. All right, so there's number 1. Like I said, I'm going to go pretty quick here just because I want to, just go through the problems. I don't want to spend too much time, but certainly if you have questions, send me an email for clarification, or just kind of see me tomorrow morning. I'll be in early tomorrow morning. So number 2, we have 2x minus 3 times 8x minus 2. So again, let's manipulate the 8 so that it becomes a base of 2. So we would have 2x minus 3 times 2. What's another way to write 8? Well, 8 can be written as 2 to the third. And in doing this, I have to multiply the exponent by the new kind of, I guess what I say, it's kind of like saying base power to a power. Because if I do this, 8 is the same as 2/3, 2 to the third power, and so therefore if I use, I forget the rule that we described it as, power to a power, we know that we multiply the exponents. So in doing this we get 2x minus 3 times 2, 3x minus 6, I distributed, and then you're just going to follow the same method there by adding the two exponents together, which we get 4x minus 9. So we add the exponents, like terms, so on and so forth. All right. Again, the hard part is finding the base. So creating a equivalent number or representation, expression to the number that's already there, the base. All right, so number 3, draw a little line there. This is the one that was causing a little bit of confusion today in some of the classes. Here, I'll put parentheses around it just to be mathematically correct. Times 5 over 3 x plus 1. So now, we have a lot of confusion here just because of the fact that I have no clue where to even start with this thing. But understand that I can rewrite 9/25 as, if you kind of look at this, let me come over here with all this kind of junk. Let's see, 9/25 is the same as, is equal to, in a way, 3 squared over 5 squared, which in turn, by one of your rules on your paper, I could say that is 3/5 squared, correct? All right, so that is a rule that when we kind of take a fraction to a power, we can distribute that power to each numerator and denominator, which kind of helps me simplify this thing. But we also know that it's flipped. So in order to flip it, I need to take the negative of it. So, for example, we have 3/5 to the negative 2 times x minus 2. Okay, so we took this, we flipped it, and then we took it to its second power. Here are kind of the rules of this. So when I took the negative 2 to this, it flipped the fraction, and now is accumulative to that thing. Okay, so now we have, let's see, 5/3 x plus 1. And so then if we distribute it like we've been doing this whole time, we have 3/5 negative 2x plus 4 times, well, 5/3. I apologize. I'm flipping this upside down. Now, that's probably confusing you. I apologize. Because I took it to the negative, it flipped over, which makes them cumulative or equal to each other. Kind of show how I did that over here. And then we have 5/3 x plus 1, because now we have the same base. We can add the two together, so we get negative x plus 5 is the equal kind of things. Okay, so hopefully that helps you with that one. Again, send me an email if you need more clarification, or come in tomorrow morning just for, if you want a couple more problems, I can give those to you in the morning. Let's see here. What other things we got? Number 4. And I'm just going to probably set these up from here on out. So number 4 is 3 to the 3x times 1 to the x, 1/3 x times 9. All right, x plus 1. Okay, we'll put parentheses around my fraction. All right, so on this particular one, we're going to make 3 as the common base. So we have 3 to the 3x, he's fine, times 3, and we're going to say to the negative 1 is equal to 1/3, so we have negative x times 3 squared x plus 1. All now they have the same base. Again, I switched 1/3 to 3 to the negative first because it just flips it. All right, that is that one. Number 5, we have 4x minus 2 equals 8, 3x plus 1. On this particular fraction, or one, we have an equation now, so we're going to have a base of 2. 2x minus 2 equals 2, 3, 3x plus 1. Now all you're going to do is, once you've had these together, because now they have the same base, we can simply put the two exponents equal to one another. All right, so that's what the equal sign means, that if the bases are the same, therefore I'm stating that these two things are equal, and so therefore the exponents are the same. All right, number 6, I'm kind of running out of room and time here, so we have 1 over 27 equals 3 to the x minus 2. All right, so what we're going to do here is we're going to switch 1 over 27 to a base of 3, which would give us 3 to the negative 3 equals 3x minus 2. And so you would put the two exponents equal to each other, and you would get your answer of negative 1, I believe. If we say x minus 2 equals negative 3 plus 2 would give us negative 1. And finally, the good old number 7, I am going to hold off until tomorrow. So hopefully you come in early, and it might be something we start with before we start the standard quiz, or you can see me before school to see if you did it correctly. Have a fabulous evening, and I apologize for the quickness, but I figured I'd go through all of them just to make sure everybody's on the same page. Have a good evening, and I'll see you all tomorrow.